Hello learners, in this video we are going to see Nyquist criterion for distortion-less transmission. Here, first we are going to see pulse shaping. To obtain the overall pulse shaping, we need to reduce the invisible interference for, by the given impulse response of the channel h of t. To construct the overall pulse response produced by the entire binary data transmission system, the receiver must be enabled to reconstruct the original data stream applied to the transmitter input exactly. That is, to obtain the overall pulse shape produced by the entire binary data transmission system, the receiver is enabled to reconstruct the original data stream applied to the transmitter input exactly. A signal design procedure, overlapping of the pulse in the binary data transmission system are configured. So they do not interfere each other at the sampling time Ta equal to ITP. To reconstruct the original binary data stream is accomplished by the behavior of overlapping of pulse outside the sampling time is clearly no practical consequence. Such a design procedure is rooted by the Nyquist on the telegraph transmission theory. It is valid then today. The weighted pulse contribution AKP of ITB minus KTB must be 0 for all k except k equal to 1 for the binary data transmission across the bandwidth channel to be ISI free. The overall pulse shape P of t must be designed to satisfy the requirement P of ITB minus KTB is equal to 1 for I equal to k and 0 for I not equal to k. So P of 0 is equal to unity according with the normalization. P of t is satisfied two part of condition. One is P of ITB is minus KTB equal to 1 for I equal to k and 0 for I not equal to k. This two part of condition is called Nyquist pulse. The condition itself is referred as Nyquist criterion for distortionless binary baseband data transmission. From the design point of view, to transform two part of condition into a frequency domain, the sequence of the sample P of NTB, where n equal to 0 plus or minus 1 plus or minus 2 on the sampling process, the sampling in time domain produce the periodicity in the frequency domain. P of del of f is equal to Rp summation n equal to minus infinity plus infinity P of f minus n nRB. We already see P of 0 is equal to 1. Here we make P of del of f. Here we make P of del of f equal to 1. Here P of del of f on the left hand side is the Fourier transform of infinite periodic sequence of delta function of period Tb, whose individual area are weighted by the respective sample of P of t. P of del of f is equal to summation integral of minus infinity to plus infinity summation m equal to minus infinity to plus infinity P of mtb del of t minus mtb into exponential of e power exponential term of minus j 2 pi f t into dt. That is, this is the given function. That is, this is the function and we take the Fourier transform for this given function. If we take the Fourier transform for the given function, we will get the P of del of f. Here this P of del of f is the convolution of h of f, c of f and uh, g of f. Let the integer, here we consider the m equal to I minus k. If I equal to k, then m equal to 0. If I equal to k, then m equal to 0. If I not equal to say k, then m is not equal to 0. If we substitute m equal to 0, p of 0 into del of t exponential of minus j 2 pi ft. Here p of del of f is equal to p of 0 integral of minus infinity to plus infinity del of t into exponential of minus j 2 pi ft. Here we know that according to the delta function property, this integral function is equal to 1. So P of del of f equal to P of 0. We know that P of 0 value, the maximum P of 0 value is equal to 1. This is the normalization value. P of 0 is equal to unity according to the normalization value. So this P of del of f is equal to 1 equal to Rp into summation n equal to minus into plus infinity P of f minus n Rp. Here, if we substitute P of 0 is equal to 1, at the time we will get the frequency domain condition for 0 ISA is satisfied when summation n equal to minus infinity to plus infinity P of f minus n Rp is equal to Tb, where Tb is equal to 1 divided by Rp. Now we make the following statement for Nyquist criterion for distortionless baseband transmission in frequency domain. Here, this frequency function P of f is eliminate the intersymbol interference for the sample is taken at the time interval Tb, and P of f is refer the overall system that has transmit filter, channel, and receiving filter. Ideal Nyquist pulse. To specify the frequency function P of f in the form of rectangular function, P of f equal to 1 divided by 2w when w less than f less than w, and 0 when modulus of f is greater than w. And this is the rectangular function 1 divided by 2w rectangle of f divided by 2w, where rectangular of f is stands for rectangular function of unit amplitude and the unit support centered on f equal to 0, and the overall baseband system bandwidth W is defined as RB divided by 2 and RB equal to 1 divided by TB. A signal function that produces 0 ISI is defined by the sinc function P of t equal to sine of 2 pi Wt divided by 2 pi Wt. Here this is the sinc function, sinc of 2Wt. The special value of bit rate RB is equal to 2W. It is called as Nyquist rate and W is called as Nyquist bandwidth. The baseband pulse P of t for distortionless transmission is called as ideal Nyquist pulse. This P of t is called as ideal Nyquist pulse. And then here bandwidth requirement is equal to half of the bit rate. The bandwidth requirement is equal to one half of the bit rate. And this is the function. This is the P of f. It is the rectangular function. Rectangular function which is nothing but 1 divided by 2w. Some in the limit this ranges from minus w f to plus w, and this is the sync function P of t. This is the P of f and this is the P of t. And at frequency 0, we will have the maximum value and it is centered at 0. The rectangular function is centered at 0 and it has the unit amplitude over the interval. And here in sync function, it has the maximum value at time t equal to 0. In this plot, we see P of f and P of t. Here, P of f is the normalized form of frequency function. It is plotted for both positive and negative frequency. And in part B, the figure. This figure is include the time domain function. This time domain function is represent the impulse response of the ideal low pass filter with magnitude response is 1 divided by 2w and bandwidth is equal to w, and the function P of t has the peak value at the origin and it goes 0 at every integer multiple of TB. Yeah, and then the received if the received waveform y of t is sampled at every t time period and at t equal to 0 plus or minus TB plus or minus 2 dB, and the pulse are sampled, the received waveform are sampled for every ti time period, and then here this is the binary sequence. The response of the this is the sync pulse corresponding to the binary sequence. Here, if the value is 1, then the sync pulse value is plus 1. If the value is 0, the maximum sync pulse value is minus 1. And this effect is called as intersymbol interference. This effect is called as intersymbol interference. There are two practical difficulty to make it undesirable. That is, the magnitude characteristic of P of F be flat from minus W to plus W and 0 elsewhere. But it is physically unrealizable and it doesn't provide abrupt transition at the band gauge. And pulse function P of t is decreases 1 divided by t for the large t, and it creates the discontinuity of P of f at W plus or minus W, and there is practically no margin of error in sampling time at the receiver, and y of del t is equal to summation k equal to minus into plus infinity ak into p of del t minus ktb. And if we expand this function in terms of sync of 2 pi w del t minus ktb divided by 2 pi w del t minus ktb. If we expand this function, sine of a minus b is equal to sine a cos b minus cos a sin b. If we expand this function, we will get the function y of del t is equal to a of sinc of 2 pi del t plus sine of 2 pi w del t divided by pi summation k equal to minus infinity to plus infinity minus 1 of power k divided by ak the whole divided by 2w del t minus k. The first term in the right hand side is defined as desired symbol, and the remaining term is represent the intersymbol interference. Thank you.